Hi all, today we are going to see the topic about semaphores, which is comes under the subject of operating systems in process scheduling and synchronization unit. So we have seen the last topics about process scheduling and synchronization. So let's recall the previous session. The last session we have seen about the critical section problem, how it is exist, and hardware synchronization is should be limited due to the reason of critical section problem, and software solutions are needed. Topics for discussion and in these sessions are semaphore definition, semaphore operations, types of semaphores, and issues in semaphore usage. These are all the topics we are going to discuss in this session. And let's explore the thing which is process can run concurrently, and shared resources need control, and semaphores provide signaling. These are all the thing we are going to explore in this session. Then why semaphore? It prevents race condition and it controls shared resource access, ensure process coordination. Uh, what is race conditions means? A resource must need for one or more process. There could be a conditions which is occur, that is race conditions. In this case, the resource should access under the controlled manner. So ensure while a process can hold that resource, the other process should not access that particular resource. Ensure the coordination while you are processing the resources. And this is what we need semaphores. And semaphore is an integer variable and is used for synchronization accessed by atomic operations. It is an integer variable. It is used to wait and signal manner to access the resource. While a process can hold that particular resource, the another process should wait for that particular resource. Once the process can complete the thing by the resources, that can be release that particular resource for another process use. This is a wait and release. It could be an integer variable in semaphore, and semaphore's operations, it is wait and signal. Wait means p and signal means p. Operations are atomic, while semaphore acquire resources. The resources state must be -1. There is a critical section problem. Section is nothing but is a code that can coordinate the process while we are using semaphore operations. And signal means the particular resource can released by the process. So the resource status should be positive. So wait operation, it decrease semaphore value. If value is less than 0, process should wait, adding to waiting queue. And signal means it increase semaphore value. It wakes waiting process and allows critical section entry. There are two types of semaphores. One is binary semaphore, another one is counting semaphore. Binary semaphore means that signal must be in a binary value either 0 or 1. Counting semaphore means the value should be increased based on the usage of semaphore. So this is the types of semaphore. And binary semaphore value is 0 or 1. It ensures mutual exclusion. The resource is available, the value is 1. The resource is not available for that particular process, the value is 0. This is similar to mutex. And counting semaphore, if the resource value is greater than 1, manages multiple resources. For example, printer flow. A printer is a kind of resources. The n number of systems can access that single printer. So if a system can access that printer, the value should be increased 1. This is counting semaphore. Problems with semaphores are deadlock, starvation, and priority inversion. And real world applications of semaphore is producer consumer problem, reader writer problem, and operating system kernels. These are all the real world applications of semaphores. Let's summarize the topics of semaphore. It manages synchronization. It uses the two thing for operations, that is wait and signal. Incorrect use causes issues. These are all the summarization topic of semaphore. And curiosity challenge, why can man wrong semaphore order cause deadlock? Think about resource holding. Discuss with your friends. You can get the solution for your questions. And thank you.